So, hello everyone. Today I'm going to present the integration between WHIDS and MISP. So, yeah, I will explain what WHIDS is in a couple of slides. So this is my Twitter and GitHub handle if you want to check my projects, and this is the project's GitHub as well. Okay, so who am I? I'm freelance security consultant, mainly working in Luxembourg for my own company. And yes, I'm mainly doing incident response, everything related to digital forensics and malware-oriented digital forensics and malware analysis as well. So everything related to incident response, let's say. And I'm also developing some open source projects, mainly in Go, that you will find on my GitHub, but also C and Python sometimes. So that's it for my introduction. So you have probably never heard about this tool, so I will present it quickly. So it stands for Windows Host IDS, even though that now it's a little bit more than just an IDS. And yeah, to be more precise, it combines the detection capabilities of an IDS with some incident response capabilities as well. So just for your information, it strongly relies on Microsoft Sysmon. So basically we can say it can be, yeah, let's say it has less features if we don't use Sysmon. And these are the main features. So it can correlate the logs on the host, which is often done offline. I mean, in common scenarios where we have a SIEM and so on. This is done on host. It can also detect in real-time suspicious events, so either from raw source logs or from the correlated logs. And the interesting part, it can react to the alerts. React means that it can dump files, process, or registry. As an example, if you see like a process that has done something malicious, it can dump the file created, for instance, the process itself, the memory, and the executable. So, and all this information can be sent to a central point. Okay. So this is a little bit a small drawing to explain you how it's designed. So basically, it's built on top of the Windows events, so you can listen to the Windows event channel. It can be any channel you want, basically, and it's fully configurable by the user. Just, yeah, sorry, I missed one slide. This is because of the remote. So why did I want to implement this tool? So that a lot of people cannot afford expensive solutions like SIEM, EDR, or whatever. So, and I would like those people to have something to hack with. So that they can basically craft the detection rules that they want and control them from A to Z. I want a scalable solution that is easy to manage, easy to deploy. And I want also something that is easily pluggable with all the other open source software that we can find today. So MISP is an example. I don't know, dHive is another. So yes, this is the goal of this project. And through the, let's say, how the evidence collection, I also want the analyst to save their time, because as an analyst, I'm often, let's say, frustrated by the time between the detection and the time of the collection of the evidence can take ages. So that's why I wanted something almost in real time. So how it works. So you can listen on any Windows channel, as I say, and then those events goes to the hook engine. The hook engine is the first pre-detection hook, I call, is to do the correlation. So it can take several events and correlate them to create an enriched event. And then those events are pushed to the gene engine. And this engine is basically the guy who is responsible of detecting something, detecting a suspicious event, and then transform this event into an alert. And the alerts are then sent to the post-detection hook, which reacts to the alert by dumping file process or the registries. So this is a quick example of enrichment. So if you are familiar with Sysmon, this is an original process create event. And this is what we can enrich the event with. So I didn't copy it, the same fields from one column to the other. So this is what WHIDS is appending to the event. So you can get the full list of ancestors to this process. You can get the image size, the parent integrity level. It's useful for privilege escalation detection, for instance, and some other fields. Another interesting one is this one. So it can list gives you the list of the services associated to this process, especially interesting for SVC host processes. So what's gene? Because probably you have never heard about it either. So this is the detection engine inside WHIDS, and this is basically the origin of everything, because I started by this project and I wanted to design a tool to match IOCs inside Windows logs, because I was always doing this by hand when I was doing my analysis. So I wanted a generic tool so that everyone can craft the rule, feed it to the tool, and just report the suspicious events. So this can be used offline, for instance, and you can use it in your forensics analysis as well. And this is packaged inside WHIDS so that it can process the logs in real time. So a rule example, these are two different rules, just to show you. So this is a rule matching PowerShell process taking some inputs in std in. So rule name, a tag, the event ID it applies to, so event ID 1, process create of the Sysmon channel, the criticality of the alert, and some metadata. I won't go into the details. And this is the important part. So these are variables, $ps and $arg. And this is basically the match. So it means I will match the image part of the event using the operator regex. So it expects regex after. And this is the regex it has to match against, so that this variable is set to true. And likewise for this one. So, and from the matches and the variable of the matches, you can create a condition. So here, if PS and arg are met, you say that it will trigger this alert. So PowerShell stdin. So if you have PowerShell process plus this regex matching the command line. Likewise for this suspicious LSAS access. So to detect Mimikatz normally. Here we see that we can also integrate the information about the attack metrics, and this will be reported in the alert as well. And we see another operator, which is like a flag operator, which checks for read access to the to the process. So yeah, there are several things to do about this format, to say about this format. So if you really want to dive into, you can look at the documentation. I won't explain more about this. So yeah, we are at the MISP summit, right? So when do I talk about MISP? I just recently integrated MISP inside this WHIDS to benefit from the MISP IOCs inside this IDS, let's say. So I had several challenges to face. So performance, because we have a lot of IOCs, and I don't want my IDS to be slow because of the high number of IOCs. I want it scalable, so I don't want the increasing number of IOCs to slow down the IDS, and I want it to be flexible. Flexible means I want sometime to match a subpart of a field and not the full field. I will explain this later. And also the case insensitivity that we have to face, mainly for registered keys and paths. So this has been mainly implemented inside Gene. So again, the format definition of the rules. So this is an example of a rule which is made to match again the query name event of a DNS query event from Sysmon. So this is an example of query name event. DNS query event. And this basically says this variable will extract this regex, so only the TLD plus domain part of this field, the query name field, and we'll check it against the MISP container. So a MISP container is basically a set data structure containing all the IOCs present in MISP. And same for subdomain and sub-subdomain. And for instance, this alert will be reported if any of these is met. So yes, what's needed to be done inside WHIDS, since mainly it has been implemented in Gene. It has to be integrated with the central manager of WHIDS. It has, I had to define a specific policy also to periodically pull the IOCs from MISP. I had to make a choice on the IOCs, so I decided to take, for the moment, only the one with the IDS flag and belonging to those categories. So basically cryptographic hashes and hostname and domain. So why I didn't take the registry keys and the file name? The registry keys is a bit tricky because you can have a variable part inside. So for instance, the seed of the user. So yes, it needs some tweaking, let's say, to make it fully compliant with what we see in Sysmon. And the file name, I didn't put the priority on this because I don't think it's a really strong IOC, meaning that we can have a lot of false positive with this. So anyway, supporting new IOC types is just a matter of adding one line of code, and I could theoretically even put it in a config file. So it's not a big deal. So if I want to add some, no problem. And the integration is now on the GitHub. So it's the latest release from today. So if you want to check it out. Yeah. Small demo. I cheated a bit. I did a video, not to suffer from the video effect, and so that I can comment in the same time. So we don't see a lot, I'm sorry. Anyway, I will put this on a GitHub. So here we see the manager running. Here it's a VM with Windows 10 running, with WHIDS running on it. And here I'm just issuing a vget on a malicious domain from found in MISP. And here we see coming in the dumped information. I'm sorry, we don't see anything. So here I will print the event associated to the alert. So we see it's a suspicious domain, and yes, we see it. And now we have to wait a little bit that the process is done, because there is a time between the dump is pushed to the manager. It's a policy not to load the network everything at a time. So we have to wait a few seconds, and yes. So we see the event, and also it should have logged the SHA of the malicious process issuing the query. I didn't remember, it was so slow. So now the dump arrived. So it's a not a full memory dump, but a process memory dump of the PowerShell process. So here we see that it's exactly the same PID as here. So I pipe it to file. We see that it's a dump, a Windows dump file. And now I'm just making a string on it just to see to show that we can see exactly the same command line I entered on the infected machine, the simulated infected machine. So, and that's it. Yeah. So this will be on a GitHub. So if you want to check it, I'm sorry we don't see. Yes, basically. So if you have questions about this. Yes?
Yeah, I have a few one. You showed your gene file format. I was wondering, when I saw gene, the first thing that popped in my head was Sigma. Because it looks the same, but it is different. I recognize some structures, but also there were some difference. I was wondering if you've already looked into maybe gluing it together. That might be cool.
Sorry. You can, on the gene GitHub repository, I have a script to convert gene to Sigma to gene. So. But again, it's a long discussion because there is no one-to-one match between the two formats. So this is something I automated, but this is something that has to be reviewed in the end by the person who converted it, because there is no guarantee that it will not raise false positives and so on. The reason is that Sigma is, let's say, based on text-based search, and this is mainly using regex. So it has to be translated from the two, and yes, I guess it's easy to find bugs in this conversion. So it needs to be checked. But let's say it can be used at least to generate the skeleton of the rule.
Over the order, I have I'm not sure to understand the whole link on how you glue into the APIs. I was wondering, are there any risks of incompatibility issues with Windows updates and newer versions which might cause crashes of the system? Or is that, depending on how you hook, is that totally not an issue? Because it's out of interest of like convincing people to use it.
So there is nothing done at the kernel level or let's say really low level stuff. It's only listening on the Windows events, and let's say the hooking is just a way to say, when I see this event, I will, let's say, take this information from this event. I store it inside my program in a structure. And then when you see another event, you just enrich this event with the data you have seen in the other event. So that's the only thing. And it's implemented as a Windows service. So it's everything user land, nothing low level. So for me, there is no incompatibility issues. Any other question? Okay, so if no question, I'm done. So just so you know, I'm also giving a training about this on Thursday. So here I had to go really quickly on several aspects, and I will really go more into detail on Thursday. It's a 3-hour workshop, so feel free to come if you want to know more about it. So thank you, guys.